So let's see our third person controller. Okay, we have separated, of course, the stuff, but I'm going to go pretty fast because you already have the scripts and the project in the starting project. Okay, so we have handle movement, handle animation, state manager, input handler. Input handler is what updates the variables in the state manager, and the state from the state manager, both handle movement and handle animation take the variables, reflect on the variables, and update everything what it has to update. Let's say the input handler. You see that I've hard coded to require component of state manager and handle movement. Okay, we start getting the state manager, and we also need to assign the camera holder. We assign the camera holder and the state manager, and the camera holder is going to be what it's assigned. That basically the transfer of the camera. We have one simple function, handle axis. It goes and updates the horizontal and vertical variables in the stage manager. So, state manager. Horizontal, vertical, if it's dummy, if we are on ground. We need reference to the handle animator and the handle movement. On start we get those references and we run their init function, which is basically the start, only it's as a public function, so we can run it like this. So it's going to go into the handle animation. Okay, the handle animation needs a reference to the state manager and the animator, of course. On init we pass the state manager, we assign it on our stage, we find the animator, we find all children animators, we do a for loop, and we find the first animator. We find that it's not the actual animator we have assigned over here. We take that avatar, we assign it into our animator, and we destroy that animator. So this way we get the controller of our own character, and we can change character pretty easily with this. On tick, which is basically the update only with as a public function, so we can call it from a different update. In our case, that update is going to be the state manager. And okay, we take the animation value. In our case, in this simple controller, will be the absolute value of horizontal and the absolute value of our stage vertical. So in any key the player might press, or WASD, in each of these keys, it's going to just make this into a value. It's going to give a value to this. However, we do not want values that are greater than 1, so we clamp this to be between 0 and 1, and then we just update the animator, which in our case it's only the movement, and it comes into the blend tree we have, into this one. Okay, idle, walk, run. Back to the state manager, we have our handle movement. We initialize the handle movement too. Rigid body, state manager, input handler, move speed, rotate speed, store direction. Move speed and rotate speed are not the actual values I'm using. I'm using 25 and 4. Okay, 25 and 4. Store direction, we will see what this is. On init we get the state manager, we get the rigid body, we get the input handler, we assigned angular drag to our rigid body, we assign drag to our rigid body, and we also assign constraints. In our case that will be freeze rotation X and freeze rotation Z. Otherwise your capsule collider is going to fall flat on his face. Public void tick, I said what tick is. We have two vectors, one vertical and one horizontal. To know if we are going to go towards where the camera is looking, we get the camera holder's position, which is the parent of the camera. We get that forward and we multiply it by the vertical. So if you are pressing W, you are moving towards where the camera is looking. If you want to move the right or left, on the horizontal axis, of course, we take the right of our camera holder and we multiply that by our state's horizontal. We reset the 0 for this, we reset the y to be 0 for both of these vectors, and if the state says we are on the ground, then we can add force to our rigid body, and the force we want to add is the normalized vector of both vertical and horizontal together. Okay, and we multiply it by a speed which is a function that returns us a float. In our case, it's going to return only the move speed. If you want to have crouch or walking and all that, you can change the speed over here and return that instead of using move speed. So if we are actually moving and we check if there is any input on our stage, vertical or horizontal, we store the direction of the direction we want to move, vertical and horizontal, normalized of course, and we add it into because this is the direction, we have to add our transform position, target direction, which is the stored direction minus transfer position, and of course we need to normalize that. We change the y. If the target direction is vector 3.0, then we assign our target direction to be transform forward, and then we have to find the rotation from that target direction. Okay, and transfer rotation will do just a simple lerp between transfer rotation towards the target rotation, rotate speed multiplied by time dot delta time, and this is the handle movement. Now on the state manager back again, okay, we see the initialization of all this. If the model, the bull over here, says that it's not dummy, then only then it's going to run the updates of the handle animator or handle animations and handle movement, and it's also going to do this function is on ground, which is if it's on ground, comes over here, finds a position a little bit above the around transform of the player. It adds a direction which is down for a distance of 0.2. It changes the layer of the player. It ignores the layer of the player. Does a recast, okay, from the origin towards the direction, and if it finds something, okay, of course, if you hit an object that has the same layer as the player, that means you are hitting a controller or another player. Okay, then if it finds something, then that means you are on the ground. Of course, you can update this and add more stuff. As I said, this is only an example controller. Okay, so if you are on the ground, then it's going to set the on-air boolean on your animator to be false, and it's going to update the rigid body drag value to be 4. Otherwise, it's going to set the drag value of your rigid body to be 0 and going to change the on-air to be true. Okay, that's basically it. We cover every script I have inside. Not every script, we actually have to do the camera. So the camera is also like this. Okay, we start our target transform, our pivot, turn speed, turn smoothing, tilt angle, tilt maximum, tilt minimum. I think you can understand all this. Smooth X Y, smooth X velocity, Y velocity, and our current look angle. On start we set the transfer position to be what we have on our target position, and the pivot is going to be the first child. You can see the rig of my camera holder, pivot camera. Okay, we've seen this 1,000 times already. On fixed update, the transfer position is going to be a lerp from our own transfer position to the target position by time dot delta time multiplied by the lerp speed. The X and the Y will get the axis for the mouse X and the mouse Y. If turn smoothing is higher than 0, then it's going to do a smooth math F smooth dump from smooth X to the actual X Okay, and it's going to reference the smooth x velocity, the smoothing, and the same for the y. Otherwise, it's going to assign the smooth x and the y to be the x and the y. Look angle is going to add on the look angle based on the smooth x multiplied by the turn speed. If look angle is higher than 360, it's going to set it as 0. If it's lower than 360, minus 360 is going to set it as 0. It's going to change the transfer rotation to be only on the y to be the look angle we have over here, and it's going to change the tilt angle. It's going to subtract from the tilt angle by smooth y multiplied by turn speed, and it's going to clamp it between it's going to clamp the tilt angle between the minimum and the maximum, and it's going to change the local rotation of the pivot to be the tilt angle. So that's all the scripts now. So let's say if I wanted to implement this into another project, what I need to take with me. So basically we need all our prefab, so let's do an export package. If you have the Bezier curve utilities, of course you do not need to include them. If you have this, basically these scripts, I already have them in my own project, so I do not need them, these three scripts, and I also do not need the controller, of course, since I've already had it into another project. Keep in mind though that because we keep this into another namespace, even if you have a state manager in the other project, you will get an error that it cannot find it. That's because we are using inside our client behavior, we say look under the namespace controller. Okay, and you have to export this. This basically covers the scripts. You also need to export your animator. Basically, if you export the package, of course you can see that it's also going to take your scripts, but if you have already exported the scripts, then you won't need this. You won't need the scripts, okay, just the animator, just so that you do not have to, you know, create the animator again, although it wouldn't be an error to create it again. Okay, so back into another project, or the project you want to add it. I'm going to use the third person shooter. We have a climbing scripts. We need to go into the client behavior. I've already have a state manager over here, of course, or basically it comes down into having a simple way to disable your previous controller or the third person controller you might have in your game. And in my case, let's close all this. Let's search actually for get component. Okay, in this case, in my project, the state manager is not under another namespace, so I deleted this and I went ahead on my state manager and created two new functions, which is what disables the controller and what enables it. Okay, I've added a boolean into this project, which, yeah, it's over here. So here's the problem. We have a lot of functions in this project, so that's why I'm not adding the climb system into the third person shooter. I'm just using it as an example. Okay, if you want to have a third person shooter with climb system, do not implement this system on a project. Okay, take the stuff we have made on this series and add it on top of the climb system. It's going to make your life way easier, trust me. Okay, this is just an example case. Yeah, although it's simple to add it, it's not tailored for the third person shooter project because we use a lot of IK. We already use a lot of IK. Okay, and yeah, it's better to tailor it so that you know what's going on also, and so that you have fewer problems later on. So In my case, for this project, because we have last stand behavior, we have cover behavior, you can see that I've completely removed the cover behavior, and because this is the new cover behavior, you will see it if you haven't seen it yet. So you have, I've added if you are not climbing and you are actually on the ground to run these behaviors, and the cover behavior will just completely remove it. If you are climbing, then run the update for the audio manager, and if you're not climbing, only then go and update the values on the on air, which is a new function we saw, okay, to be the opposite of the on ground. And exit locomotion will also be the on ground. So for the animator, what I did is basically copy paste my entire state tree. Now if you are going to copy paste Unity state manager like this in 5.3 and probably in lower versions or earlier versions, if you paste it and have the same names on in my case the locomotion state, it had the same name as the other animator, so that gave me errors, and basically yeah, I ran across into a bug anyway, so ignore that. Just copy paste the stuff you see over here and recreate the connections. Okay, dismount end. When the dismount end ends, you're going into the locomotion state, and the third person shooter is going to take on from that. On air, if you are not on air, then move into the on air state. If you are, then if you are not, yeah, I said it the opposite way. If you are on air, then go to the on air state, else go to the locomotion state. Okay, that's it for the animator. You of course need to add the new parameters, and you see why I do not want to keep this to this project, the climb system, because it gets out of hand pretty fast. So you have to tailor it to be working with a climb system instead of just adding a climb system. So let's see what else we need to add. And yeah, this is the stuff that has to do with the state manager basically. And yeah, I think we've covered everything. And what I'm also doing, when I'm disabling the controller, I enable climbing, I enable dummy model, I make my rigid body kinematic, I make trigger my collider, I switch weapon with target weapon, in this case with the unarmed weapon, and I also use I enable the climb AK, because when I have enabled the controller over here, I actually want to have the climb AK disabled. Okay, climbing false, 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 all false. We basically reset what we do over here, and you can also switch weapon with a previous weapon if you want, but I feel there's no need for this. Okay, and we also reset the constraints for the rigid body, because I think, yeah, although this might not be necessary since I've disabled the cover behavior, so that's why these probably are not even necessary. Okay, basically these are the stuff you have to do, and of course I will also suggest the collisions for your climb grids to be on a different layer that's only for them. In this case it's going to be the climb spot, or you might want to tailor it a bit further. As I said, I didn't want to start doing stuff for this project, to the climb system for this project, because yeah, it gets out of hand pretty fast, and it's basically out of scope of what I have in mind for this project. Okay, so we saw how we can implement the climb system into another project. As I said, your life is going to be way easier if you start developing starting a project that has to do with the climb system from the start, and instead of just implementing the climb system, it's better to build upon it. And as for this project, I will handle both climbing and vaulting and all that completely differently, or yeah, some stuff will also be the same, but mostly differently, and that's why I didn't want to add this into the same project. Okay, we talk about how you can add your project so as I was saying, we talked about how you can create a climb system, how you have to set up your level to use the climb system, and what you have to do on your controller to use it, how to set them up, how to use the AK, how to use the AK to have dynamic placement of your hands, as we can see. So we can go diagonally, how we can override the automatic connections to tailor it a little bit better. Okay, so I think we are pretty much at a good position, and the best starting position, I think, if you want to create a game like Assassin's Creed or Uncharted or whatever you want to have. Okay, this system I think is pretty powerful, and of course we're going to keep adding more stuff and continuing on and on. So you know what to do. Hit that like button, subscribe if you haven't already, and if you like what we're doing here and you like to see more stuff like this, then consider supporting me on Patreon or on Gumroad by buying a project or two, including the third-person shooter, including the climb system, and including many more. So I'll see you next time.